Hi students, let's now understand sp3d2 hybridization. Okay, now check students, how can you be able to understand? So sp3 and d2. In this one, what is there student? That is one s orbital. This is one s orbital, and p3 is there. Pq means that is 3p orbital. This is what student 3p orbital. THREE p orbital. And how many d are there student? You can find that is 2d orbitals are there. So these are there. Of total number of orbital, how many participating student? So that is, here you can write 1 plus 3 plus 2. So how much? 6 orbital. So when you are talking about 6 orbital are going to hybridize, so if 6 orbital are going to hybridize, it means 6 new orbital will form. 6 new orbital, because here s orbital is spherical, this will be dumbbell, and here they will be the double dumbbell shape, right, like that. So these different shape orbital are going to join, and what is going to find? They are going to form the 6 new orbital, right, and they will arrange in the tetrahedral manner that we will tell you in the with the help of example. So first of all, you try to understand what is the meaning of sp3d2 hybridization. This is 1s orbital, 3p orbital, and 2d orbital. Example, if you are talking student, this is a sf6 molecule, sulfur hexafluoride. Now sulfur hexafluoride, how many 6 sulfur fluorine are there? So 6 bond present, 6 bond present. Now to understand the hybridization, 6 unpaired electron required. No, 6 unpaired electron required. This is what is the meaning. 6 unpaired electron required student. Now student, let's see the configuration of sulfur. This is the going to be 16. Here is 1s2, this is 2s2, 2p6, this is 3s2, 3p4, and 3d0. Now let's try to understand what is the distribution can be student. And here is, there is no electron in the d orbital. Now you fill the electron here, that is 2, 1, 2, 3, and this is going to be 4. Now total here in this case student, that is 2 unpaired electron is there, but required, how many required? 6 unpaired electron required. So what we are going to do student, this is the ground state configuration. This is the ground state, and we are going to send it into the excited state. Let's see sulfur 16. So in the first excited state, this is the first excited state. Okay, so in the first excited state, one electron you are going to excite from where to where student? This p orbital to here, it is going to jump here. So this is the inner electron, as it is 1s2, this is going to be 2s2, 2p6, here is 3s2, 3p3, and 3d1. Now see, now in this case, how many unpaired electrons are there student? So if you talk about unpair 1, 2, 3, and in the d orbital also usually you will find that is 1 is there. So total n value here it was, that is 2, now n value become to 4 unpaired electron. Now but how many required student? We required 6. So again, that is sulfur 16, you are going to send one more, the second excited state. This is what is student, second excited state. So if you are sending second excited state, dear student, so what you are going to observe here? This is 1s2, 2s2, 2p6. There is nothing to do with the inner orbital electron student, only we need to check out the valence electron. So it is going to be 3s1, 3p3, and 3d2. Now let's see. This is one unpaired electron. In this case, what is there? That is the 3 unpaired electron. And here is, you can find student, that is 2 more unpaired electron. So n value, how many are there student? 6. 1, 2, 3, 4, 5, 6. Right. Now these are going to participate in hybridization student. Okay. So what are there student? 1s, 3p, and d2. So total how many new orbital will form student? 6 new orbital will form, going to be formed. So 1, and they all are having the same shape, same energy, everything will be the same student. So that is 4, this is going to be 5, and here it is going to be 6. Now they are going to rearrange, student, you know, rearranged. So how it is going to rearrange, student? So that is in octahedral shape. Octahedral shape. Octahedral shape. Let's see what is the octahedral shape, dear student. So here is sulfur. So what it can be, that is one orbital is like that, one, then second is here, third is here, fourth is here. So 1, now this is the 1, and here is the again going to be 1. So this is going to be the 6 orbitals we have made, right? And here is, this is the orbital is here. This is what is this is this. So up now sf6 is there na. So fluorine you know, student, fluorine 9. So 1s2, 2s2, 2p5. So which orbital is having the unpaired electron, you can find. So 3, 4, 5. This orbital is unpaired, and this shape is what is dumbbell shape na. This is pz orbital. So that is fluorine, that is z orbital are overlapping. So this is what is the one fluorine. This is another fluorine. This is one more fluorine. Here is the fluorine. Fluorine atom. And lastly, this is also going to be fluorine. So these are the octahedral shape of sf6 molecule. So you can write that is octahedral shape of sf6 molecule. Okay, that is what is sp3d2 hybridization. So this is all about our answer, student. You may find little bit difficulty, but it is okay for learning. So in the ground state, only 2 unpaired electron. Then first excited state, 4 unpaired electron. Second excited state, 6 unpaired electron. This 6 orbital going for the hybridization, sp3d2 orbit and hybridizations. 6 new orbital form with the equal energy, equal shape. They rearrange in the octahedral manners. So this is what the shape of sf6 molecule. So if you are writing like that, student, sulfur is here. So one fluorine is here, that is another fluorine, and here is fluorine. So this is the square planar. Then one sulfur fluorine will go here, another will go here. So you will find that is what is octahedral shape. So this is what is octahedral shape. So this is all about our required answer, student. Thank you so much for watching.